Welcome to week 7 of our Principles of Microeconomics video series. Last week we looked at the concepts of consumer surplus, elasticity, and we took a first pass at what's called the producer's problem. If you're shaky on those concepts, you want to check out past videos, click on the link here. In this week's video, we're going to revisit the producer's problem, but we're going to focus on a particular firm, the Wisconsin Cheesemen, and we're going to look at their particular problem. It's real world data, comes from one of the authors of the paper, and we're going to look at how that data helps them to decide what to produce, how much to produce, and whether or not they should enter or exit a market. We're also going to use some graphs to illustrate the same concepts that we talked about in our last video. Let's get to it. So last week we looked at the example of the doodad production firm, and in that example we worked out that there were some levels of production and some associated marginal costs, and we figured that if the price exceeded the marginal cost, then the firm would produce, and if it didn't exceed the marginal cost, they wouldn't produce. That's a simplifying assumption, and there are actually some caveats that we need to consider. In particular, we need to consider whether or not the firm can be profitable. And this applies particularly towards that lower end of the supply curve. Are those low prices just covering marginal cost, or are they covering all of your costs? Can you actually be in business and cover those fixed costs of production as well as those marginal costs? So the supply curve for a firm is equal to the marginal cost, but only if they're profitable. And on screen, I've got a table of the supply relationship for this doodad production firm. And in the table, what you can see is that at a price of $3 and $3.25, the firm actually loses money. But because there's a fixed cost of $5, producing is still better than not producing. When the price is $3, they can just cover their marginal cost of production. They lose $5, total revenue minus total cost being negative $5. That's equal to just producing nothing and paying the fixed cost. When the price is $3.25, they can produce 9, but they lose $3.75. And you might say, well, why not just get out of this business? Well, sometimes it's not that easy. Sometimes you have fixed costs that you can't get rid of. Maybe the stapler, they've leased it for a year. There's nothing they can do. And so they have to pay that fixed cost of the stapler. If the price is $3.25 and they produce 9 units, they lose $3.75. If they produce 0 units, they still have to pay the fixed cost, so they lose $5. So producing something is better than producing nothing. Even though they're making a loss in both cases, the loss is not as bad if they choose to produce. But fixed costs are only fixed for what is called the short run. The short run is the period of time in which fixed costs cannot be changed. The alternative is the long run, and the long run is a period when fixed costs can be changed. Let's take a look at that concept. So we just saw that in the short run, when the firm has to pay its fixed costs, it's actually better to produce something rather than producing nothing. But in the long run, because you can't cover those fixed costs, it makes sense to shut down. And on screen, I've got the short run supply and the long run supply. And what you can see is that there's a difference at those lower prices. In the short run, you produce, but in the long run, you don't. When you can get rid of those fixed costs, what's called the long run, you can always make a different choice and you can get rid of those fixed costs and produce nothing, and it costs you nothing. So your total profit is 0, you produce nothing. On screen, I've got the long run supply curve, and it's different to the short run supply curve. The quantity supplied is 0 at those lower prices, 3 and $3.25. In the long run. In the short run, it's better to produce. So let's take a look at the example of the Wisconsin Cheesemen. And one of the authors of the book is actually someone who used to work for the Wisconsin Cheesemen. They're a gift basket cheese production company. And on screen, I've got the table of information about the production, the number of workers, the average, the total, and the marginal cost of producing various amounts of the good. And I've highlighted one row in particular. We're going to assume that the price is $1.13 per unit, and therefore the firm is going to produce up to the point where the marginal cost is $1.13. That's at a level of output of $12.25. Where does that price of $1.13 come from? It comes from the market. The market is the interaction of buyers and sellers. So there are other companies who produce gift baskets of cheese. There are lots of consumers of gift baskets of cheese. And in that market, by the interaction of supply and demand, the price is determined to be $1.13 per unit of the good. So the firm, the Wisconsin Cheesemen, has to take that price as sort of given. And so in the diagrams on screen, you'll see that the price basically transfers across from the market over to the individual firm's problem. And what you can see then on screen is that the price of $1.13 interacts with the marginal cost curve. And what you can see is that at a price below $1.13, the marginal cost is below the marginal revenue that you would get from producing something. So you would make more money by producing more, so you do. If the price is below the marginal cost, then you should produce less because it's costing you more than you're taking in terms of revenue. And in that way, we can say that the firm will produce at the point where the marginal cost equals the marginal revenue. The marginal revenue in this case being the price of the good determined in the market. But like we said earlier, there's a caveat. We have to check that the firm is profitable at that level of output. So to determine profit, we take total revenue and we subtract total cost. And total revenue in this case is $1.13 times 1,225 units. That's the total amount of revenue that they take in, the price they sell it for, times the quantity. You subtract the cost. And in the table, we can see that the average total cost of producing is 93 cents per unit at an output level of 1225. So what do? We say, well, total cost is going to be equal to average total cost times quantity, because if you just rearrange the formula, the average total cost is equal to total cost divided by quantity. A simple rearrangement will tell you that total cost has to be equal to average total cost times quantity. So we multiply that 93 cents average total cost times 1225 and we get the total cost of producing for the firm. When we put that into a calculator, $1.13 times 1225 minus 93 cents times 1225, we get an answer that the profit of the firm is $245. So yes, they are profitable. So that is the true level of supply, 1,225 units at a price of $1.13. On the graph of this problem, where we've got marginal revenue as the blue line across, the marginal cost curve as the red line that goes through the center of the graph and is increasing for every level of output, and the green line is the average total cost. What you can do is you can represent profit as the difference between total revenue and total cost. And on the graph on screen, you can see that the total revenue of the firm is the shaded area that has a base of 1,225 units and a height of $1.13. That's a rectangle that has an area equal to the total revenue of the firm, $1.13 times 1225. We can add in a darker shaded area that represents the total cost. That has a base of 1225 as well, and the height here is 93 cents because that's the average total cost of producing each unit of the good. So that rectangle represents the total cost of producing the good. And the difference between them has to be the profit. And it's 20 cents, the difference between 113 times 93 cents, multiplied by a base of 1225, that's $245, which is exactly the same answer we got by doing it by working it out with a calculator. And so subtracting the area of the total cost from the total revenue leaves you with a small area of profit. So using the same information, let's think about what would happen if new competitors enter the market. Well, the supply curve in the market will shift to the right because firms might enter because they see these profits being made by the producers. And in particular, the Wisconsin Cheeseman is making a profit. And so they can expect that people will try to come into the market and compete with them. The shift in the supply curve to the right, as you can see in the graph on screen, is going to lower the equilibrium price. And in this particular case, the price falls to 84 cents. So now that 84 cents gets transferred across to the firm's particular problem. They've got their marginal cost that increases from left to right, and they've got now the marginal revenue of 84 cents. Now they produce where marginal cost equals marginal revenue, but that's at a different point. Let's draw the solution to this problem on the whiteboard. Okay, so taking a look at this problem, what I've done on the whiteboard is that I've already drawn in the marginal cost curve, the price, or what's called the marginal revenue curve, and the average variable cost curve and average total cost curves. And what we can see is that at a price of 84 cents, P equals 84, we go across to our marginal cost curve and we get our supply of 939. We can say that that's the solution to the problem, but we also need to check for profit. And I've already got that profit worked out here on the whiteboard. At an output level of 939, the total revenue of the firm is going to be 939 units times 84 cents, subtracting the total cost, 939 times 90 cents, because the average total cost times the quantity will give you the total cost. Then the profit, if you work out those numbers, will be negative $59.15. So you might say to yourself, they do not produce 939 units of the good at a price of 84 cents because they lose money. But you have to remember that in the table, there's a fixed cost of 200. So if they produce Q equals 0, their fixed cost equals 200, and so their profits will be equal to negative 200. So until they can get rid of those fixed costs, it's best to continue producing where you only lose negative 59 versus losing negative 200. And until the long run comes, you can't actually get rid of that fixed cost. That's the definition of the long run. You can see that the firm is losing money in the graph because at an output level of 939, the average total cost, if we go across, is going to be that 90 cents that we just figured out from the table. And the area here between the price and the average total cost, with a base equal to 939 and a height of 6 cents, 90 cents minus 84 cents, that's going to give you the economic loss, which is the term we use for a situation where there's a negative economic profit. So in the short run, this firm should just stay producing and produce 939 units and lose $59 and some change, because that's better than shutting down and losing something like $200. If the price were to fall, and were to fall well below the average variable cost curve, if the price was to fall down to, say, I don't know, 50 cents, and you go across to the curve here, you would find that the marginal cost curve and the marginal revenue curve, this is the price equals marginal revenue of 50 cents, you'll find that they'll hit here and you'll have some level of production, maybe it's 600 units. But if you go up to the average variable cost curve, you'll find that the average variable cost of producing those units, the average variable cost exceeds the price. And if that's the case, then you should, what we say, shut down. Okay, you might need to watch that example a few times to really get it. The idea here is that firms enter the market, the price falls. What happens? Well, the firm now produces less, they make lower profits, in fact they lose money. But that's actually not as bad as shutting down. So they continue to produce, they lose a negative amount. They're hoping that competitors will increase their prices, or the market price will improve, or competitors will leave the market. And if they don't, in the long run, because the average total cost now exceeds the price, they're going to have to exit. They're going to have to quit producing this product, and they're going to have to shut down their company for good. So in that example, we saw that the firm was not profitable at a price of 84 cents. And if that continued in the long run, if their competitors were able to charge lower prices and still survive, then it would have to be the case that the Wisconsin Cheeseman exits the market, just like firms like Blockbuster and Toys R Us have in recent years. They just aren't able to compete, and sadly, they go out of business. But consumers are best served because the remaining competitors are the ones who provide the best product at the best price, as determined by the consumer. That's enough for this video. So hopefully you are more comfortable now with the producer's problem, about thinking about issues of marginal cost and marginal revenue and average total cost and average variable cost, and can understand how these things all relate to one another when determining the supply of the firm. The key thing that you need to remember is that in the short run, as long as the price exceeds the average variable cost, then the firm can continue to produce. In the long run, the price has to exceed that average total cost in order to produce. And if firms make profits, they're going to encourage other firms to enter this market. And so the price is going to fall, and in fact the price is going to equal the average total cost in the long run, which is wonderful for consumers. In the next video, we'll examine that in greater detail. I'll see you in the next one.